Hi dear students, welcome back to ESM Math tutorial. So in this video, I am going to discuss the few more basic formulae and its derivation with respect to Laplace transform. So in the last class, I have derived the formula for sin at, cos at and Laplace of 1, Laplace of e power at. I have done only cos at, but sin at I told you people to solve, but some queries came to me again, sir, you have to solve sin at also. Today I am going to cover that part also. See, today I am going to cover a few more important results with respect to Laplace transform. We will go one by one. See, in the last class we have done Laplace transform of e power at, Laplace transform of sin at, cos at, Laplace transform of 1. So now I am going to solve Laplace transform of sin at also. Laplace transform of sin at. So we know the definition of Laplace transform. What is the definition of Laplace transform? See, Laplace transform of f of t is nothing but integral 0 to infinity e power minus st f of t dt. This is the definition of Laplace transform. So in place of f of t we have sin at, that is Laplace transform sin at equal to integral 0 to infinity e power minus st into sin at dt. See, e power something is exponential, it is also infinite series, sine is also infinite series. For two infinite series, we cannot apply integration by parts. It is very difficult and tedious. So to avoid that confusion, what I will do, there is a formula in integration. What it says, integral of e power ax into sine dx, that is equal to e power x divided by a square plus b square into a sine bx minus b cos dx. This is the formula we have in integration. So we just compare this and thus we can directly substitute the values of a and b in the formula, then we can easily evaluate. Okay, therefore Laplace of sin at, that is equal to integral 0 to infinity. I have already written, I will write directly answer here. What is the formula? Says e power ax, in place of a we have minus s, in place of x we have t. So what happens? It is e power minus st divided by a value is minus s, that is minus s whole square, b value is a here, that is a square, into a is minus s sin bt, b value is a, therefore I will write sin at minus b, that is a cos at, between the limit 0 to infinity. So for constant terms I will take it outside, that is 1 divided by s square plus a square, remaining term is what, e power minus st into minus s into sin at minus a into cos at, between the limit 0 to infinity. This is equal to 1 divided by s square plus a square. If you operate infinity for every term here, it becomes e power minus infinity. E power minus infinity is 0. 0 into something is 0. Minus lower limit, what happens? E power 0 is 1 into sin 0 value is 0 because t is here. 0 into something 0, it becomes sin 0. Sin 0 into something is 0. Minus cos 0 value is what? 1. 1 into a is what? A. So minus into minus plus, therefore Laplace of sin at, that is equal to a divided by s square plus a square. Very important and simple result, my dear students. You can easily solve it. Only it needs practice. Okay, so practice 1 or 2 times, you can easily do it. Then we will move on to one more important property or result of Laplace transform, that is t power n, polynomial. how do we deal with polynomial terms? That is very, very important here. We know how to deal with exponential term. We know how to deal with trigonometric terms. Just now we have finished that, and then I move on to the polynomial term, that is Laplace transform of t power n. So what happens is Laplace transform of t power n. So a solution I will simply write here. We know that Laplace of f of t. What is Laplace of f of t? That is integral 0 to infinity e power minus st f of t into dt. So in place of f of t we have the term t power n, where n is a positive integer here. So otherwise you just write n based on the nature of n. Will segregate formula again. I just simply consider n is greater than or equal to 1 or 0. So what happens here? Integral 0 to infinity e power minus st, it becomes what? T power n dt. Again you can see here, I cannot integrate by parts because it is exponential polynomial. Both are very difficult if I go by parts method. So that's why I will go for substitution. What substitution I will consider? Put some st equal to x. What happens now? S into dt equal to, it becomes dx, or dt equal to, it becomes dx by s. Whenever we take substitution for definite integral, we have to check the limits also, because we are converting all these t terms into x term. That is the reason. So what happens? If I consider t equal to 0, corresponding x is also 0. When we consider t equal to infinity, because upper limit is infinity something infinity, x is also infinity. Therefore, there is no change in the limit, x is also varying from 0 to infinity. Therefore, Laplace of t power n, that is equal to integral 0 to infinity e power st have taken as x, therefore it is minus x t power n. See, from this I will get t. St equal to x means t equal to what? X by s. Because I wanted to convert all t terms into other variable, so I should not retain any t value in the formula or problem. So e power minus x by s into dt. What is dt value? Dx by s. So this is equal to, you can see e power, this is n, power n, I forgot. Now this s power n and this s, if I take outside, so what happens? That is integral 0 to infinity 1 divided by s power n plus 1, because s power n, s power 1, when bases are same we can add the powers. We left with e power minus x into x power n dx, that is equal to 1 divided by s power n plus 1. There is no x term associated with this. I will take outside. Remaining is integral 0 to infinity e power minus x power n dx. This is equal to 1 divided by s power n plus 1. This is standard formula in integration. So it is nothing but gamma of n plus 1. So answer is gamma of n plus 1. Therefore, Laplace of t power n is nothing but gamma of n plus 1 divided by s power n plus 1. So this is one more formula. This formula is applicable for all n values. When we have n as a positive number, so what happens usually? Gamma of n plus 1 is treated as n factorial. Therefore, based on the requirement, we can rewrite this formula as Laplace of t power n equal to n factorial divided by s power n plus 1 also. See, this formula is very useful when fractional values of n. Then this is round number, closed number, whole numbers. Okay? So Laplace of t power n equal to n factorial divided by s power n plus 1. So these are very, very important. I hope you can follow this. Then two more formula I am going to derive, that is hyperbolic functions. because they also plays very important role in simplification of problems. So what is hyperbolic function? Say cos hyperbolic AT. I wanted to find out Laplace transform of cos hyperbolic AT. So solution here. First, I should know what is cos hyperbolic AT in terms of exponential term. That is e power AT plus e power minus AT divided by 2. So therefore, Laplace of cos hyperbolic AT can also be written as Laplace of e power AT plus e power minus AT divided by 2. Because we know Laplace of e power AT, that's why. So this 1 by 2 I will take it outside. So Laplace of e power AT plus Laplace of e power minus AT using linearity property of Laplace transform. This Laplace operator is applicable for this element also and this element also. And we know the Laplace transform of e power AT, that is 1 divided by s minus k. And this is 1 divided by s plus k. Okay. So what happens if I take LCM? This becomes s plus k plus s minus k divided by a plus b into a minus b, s square minus a square 1 by 2. So this is equal to 1 by 2. Here minus a plus a cancel. This becomes 2s. 2 and this 2 cancel. Or else you write one step again here, 2s divided by s square minus a square, that is equal to 2 and 2 cancel, it is s by s square minus a square. Therefore, we conclude that Laplace transform of cos hyperbolic AT equal to s divided by s square minus a square. Now I will give one assignment for you people, dear students, please practice. Laplace transform of sine hyperbolic AT, you have to find out. See, we should know what is sine hyperbolic AT in the form of exponential terms, that is e power AT minus e power minus AT divided by 2. And if I simplify like this, I can easily get the answer. So that's it for the today's session. Very simple. These are the all basic formulae we should remember. See, what are the things we learned from the first video and second video? I'll just quickly revise. That is Laplace of 1. What is Laplace of 1? 1 by s. Then Laplace of e power AT, that is 1 by s minus k. Then Laplace of cos AT. So what is Laplace of cos AT? We have, that is s divided by s square plus k square. Laplace of cos hyperbolic AT, that is s divided by s square minus k square. Then we have Laplace of sine AT. Laplace of sine AT is a divided by s square plus k square. And Laplace of sine hyperbolic AT, that is a divided by s square minus k square. And Laplace of t power n, that is gamma of n plus 1 divided by s power n plus 1. These are all basic important formulae with respect to Laplace transform. Please remember this. In the next video, we will going to solve problems using this formulae. Okay, I hope you enjoyed this session. Thanks for watching. Kindly, if you are not subscribed my channel, subscribe and share with your friends and those who needed it. Thank you all.